Okay.
Okay.
Discrete
So
mathematics, ladies and
right.
gentlemen.
So okay. All right. All right. So we're uh this this lesson should take about an hour, and then after that you can tell me what do you want to do after. We can continue on. I got a book on probability, and this is like one section out of it. So I can continue on with probability, or we can do something out of precalculus. All right. So one of the basic principles in discrete mathematics is this concept that I'm going to talk about now is if if you have several tasks that you can do, called tasks, right? And
Hey, can we
uh,
can we try something? Can you take the mic off of your shirt and then put it on the desk in front of you or the table in front of you?
okay, okay, that better? Or?
That is kind of better, yeah.
Yeah. Okay, great. Okay, so uh, uh, so you have several tasks to do, right? And uh, each task has a number of ways you can do that task, right? Um, so I'm going to do. I hope this isn't confusing. We have N1, N2, N3. You ever seen subscripts before in algebra?
No.
Oh, okay. All that means if you see a a letter with a subscript like one, two, or three, that's just so there are three different variables, and it just means somebody they don't want to think of another letter. So we have N1, N2, N3, right? I mean, if that can confuse them, we can go X, Y, and Z. But get used to that in algebra. That instead of coming up with a new letter, they just put a subscript on it. So so I don't know. That might. I'll just go with X, Y, and Z, right? Where you have task one, there are X different ways. Okay, so uh, yeah. So what a subscript? If you're going to write it like that, you'd have N and then a tiny little one next to it. All right.
Oh, okay.
Oh, you
Okay.
see, it'll be a
Yeah.
subscript. So you want to go X, Y, and Z, or you want to go N1, N2, N3? So just decide what do you want to use for variables, X, Y, and Z, or N1, N2, N3? Okay. All right. And all right, all right, so we're going to stick with that. And the reason why we use subscripts is so that we can have like 10 variables and we don't have to come up with 10 letters. So we can just go, N1, N2, N3 up to N10, right? So it kind of makes things easier because you can end up with I think you'll even see that in computer science where when in programming, right? And you'll have a variable, you'll have an array n, all right, and then that. Are you familiar with programming?
Yeah, yeah, I know what
Okay,
arrays are.
right, right. You have an array, and it might have 10 different locations in that array. And to specify each location, you'd have, N1 and you'd use subscript. So this idea is used both in algebra and in computer programming. All right. So so you have task one, task two, task three, right? So task one can be done n one time. So these are numbers, right? And then task two can be done n two times, right? And then task three n three times. Now, as an example, and I used this before. Let's say uh, you have a menu and at a restaurant, and you have appetizers, main courses, and desserts. And you can, and so there are 5 different appetizers, 3 different main courses, and 6 different desserts, right? That's your N1, N2, N3, 5, 3, and 6, right? So the question is, if you're doing 3 different things like this, right? How many outcomes can you get, right? And so in this example, it would be 5 times 3 times 6, right? But I mean, in general, it would be N1 times N2 times N3, right? That is the total number of outcomes. Do you understand that?
Yep.
Okay. So in this example, 5 times 3 is 15, and 15 times 6 is 90. Okay. So there are, using the example with the menu, 5 different appetizers, 3 different main courses, 6 different desserts, and your task is to pick one from each. So there are 5 ways to pick an appetizer, 3 ways of picking a main course, and 6 ways of picking a dessert. So you would multiply each one of those. Okay. So this is like a general principle in discrete mathematics and in probability. Okay.
Okay.
All right. You're cool with that, right?
Yep. I'm just trying to think of a way to kind of write it on the screen.
Oh, well, I mean, you could, task 1 can be done N1 times, task 2 can be done N2 times, and task 3 can be done N3 times. And so the total number of outcomes you can do, it would be N1 times N2 times N.
Why do I keep wanting to dot this as an I? So maybe like that.
Oh, right. And then that's the total number of outcomes you would have. Okay. All right. So we're going to use that. All right. And so we're going to move on to something else, but we're going to use this concept.
Hey, Mafovich. Thanks for dropping in. We have a viewer, Mr. Kevin.
Oh, great. Yeah.
He is a huge nerd.
Oh, okay. Well, if we get an audience, I brought up before any suggestions in mathematics. We can continue on with probability, statistics, or trigonometry, or anything pre-calc. So if anybody has suggestions, we'll take them. Okay. All right. Now we're going to use this concept, all right, to pick out out of a group of things, right? We're going to pick out how many arrangements that we can pick out of that, right? But we have 2 different ways of we can do it with order or without order, right? And so let's say you have 3 items, A, B, C. Okay. All right. And so with order means AB, right, and BA are two different things, right? That's with order, right? Without order, they're the same thing. Right? Order doesn't matter, right? So we're going to do with order, and it's also called a permutation. Now on your calculator, right, you'll see a P, right, and then to the left will be an N, and to the right will be R. Maybe you ought to write that down, right? Because that's what we're going to explain.
All right, so a P and then an N.
Yeah, but
and
the
an
N
R?
it's N, not, well, they're going to be like a subscript. Okay.
Oh, okay.
Right. You found it on your calculator, right? So you're going to have a big P, and then to the left will be N, tiny N. All right. And then to the right will be a tiny R. Okay. All right. Yeah. So that's going to be a button on your calculator, right? So I'm going to show you, if you don't have that button, how you would do this, right? All right. So what that means is that you have N items, right? And the question is, how many groups can you pick out with size R, right? And so, like in the example I gave, ABC, N equals 3, right? And then R equals 2. Okay, so we have 3 items, and we want to pick out 2. And so the question is, how many ways can you pick out 2 items with order? Okay, do you understand that?
Yep.
Okay, all right. Now, before I get to that, let's say you have, well, let's just stay with 3 items. We have 3 items, right? And let's say you want to okay, so I want you to write down 3 blanks next to each other. Okay, and you have 3 items, and you want to know how many ways. And in this case, this is the extreme example where N equals R. So you want to find, we have 3 items, A, B, and C. And the question is, how many ways can you pick 3 items out with order, right? Now, without order, there's only one way. It's just A, B, C.
Yeah.
Okay, right. But now, this is how we're going to use that principle I showed you before. Now, on that first blank, right, we have 3 items, right? And how many ways can you fill up that first blank?
3 times. 3 ways.
3 times. You're right. Okay,
Yeah.
great. All right. Now, you've taken, now you filled that up, right? So now you're down to 2, right?
So do I need to put a 3 here to indicate?
Put a 3 there.
Okay.
Yeah. All right. And so that is our first task, right? Remember I said task 1, task. Our first task is, on that first blank, how many ways can we fill that up? And you're correct. There's 3 ways now. Well, after you've filled that up, right, now you're only down to 2 because you used up one of those. It doesn't matter if it's A, B, and C. You used up one of them. So you only have 2 items left. So how many ways can you fill that up? 2 times.
Yep.
And now you have 1 left, and there's only 1 way to fill that up. Now, remember what I said, that you have 3 different tasks?
Mm-hmm.
Well, that means and here you had 3 ways of doing the first task, 2 ways of doing the second task, and 1 way of doing that. And so you would multiply those 3, and that's 1 times 2 times 3, right? And that is 6, all right? So, um, now there is another term for this, and this will be on your calculator, right? This is 3 factorial. You ever seen factorial before?
I don't think so.
Okay. See if you can. You have your calculator with you?
Yeah.
Okay. Notice well, on your calculator, you'll have n with an exclamation mark. Do you see that?
I have an X with an exclamation.
Okay. All right. Yeah. That whatever. X. Yeah. So either be an X or an N. All right. What that means is that whatever number you put in there, you put in a 5, that'd be 1 times 2 times 3 times 4 times 5, which I think is 120. Okay? So that's what that means, is you're multiplying all the integers from 1 up to that number. Okay?
Okay.
All right. So, all right. So if you have n items, right, and you want to know how many ways to choose n of them with order, it'll be n factorial.
Okay.
See that?
Yeah.
Right? Because that would just continue on. If you had 5 items, right, in the first blank it would be 5. You used up 1, and the second blank would be 4, then 3, then all right. So this is, you have n items, and you're gonna order all n of them. So there are n ways of ordering these. Okay. I mean, n factorial ways of ordering these. Right. Now, before we move on, when it's less than n, let's say, well, first let's go back to the example. All right, you have 5 items, the A, B, C, D, E. You have 5 items, so you'd have 5 blanks, right? And it would be 5, 4, 3, 2, 1, right? All right. All right. So, all right. So, let's say, yeah. So, all right. So that is, and then you multiply that out. That's 6. Yeah. So that's 120 ways. All right. Of ordering 5 of them. All right. All right. You see what I mean? All right. That's, yeah. So that's 5 factorial. Right. And so there's 120 ways of ordering 5 items. Right. But let's say you don't want to do all 5. You just want to pick out 2. Right.
Okay.
Well, you said there's 5 ways of picking the first one, and there's 4 ways of picking the second one. So we stop. That's all we want. So there are 5 times 4 is 20. So there's 20 ways of picking 2 of them. Do you see that?
Yep.
Okay. Right. So all right. So what I want to do show you now is mathematically how do you express that as a formula, right? Because let's say if you wanted to pick 3 items, it'd be 5 times 4 times 3, which would be 3 times 20 is 60. All right. So there's 60 ways of picking out 3. Right. So I've all I need to do now is show you the formula. Right? Now, so first we need some background on how to work with factorials. Right? So let's go, write this down. Let's say 7 factorial equals 7 times 6 times 5 factorial. No, 7 times 6 times 5 factorial.
No.
Yeah, on that first 7, make that line bigger so people will see it's an exclamation mark. On the first 7, just make it a little bit bigger so people know what mark we're using.
The 7?
The 7 on the left side. No, the 7 on the left side.
Okay.
Okay, just make it big. People know that we're using an exclamation mark there. Okay, right. So, and then take away the exclamation mark on the 6. So that 7 times 6 times 5 factorial. Okay, right. So now does that make sense?
Not entirely.
Okay. Well, what is 5 factorial? That's 5 times 4 times 3 times 2. All right?
Uh-huh.
And so 7 factorial is 7 times 6 times 5 times 4 times 3 times 2. So I can take any part of that and just make it factorial.
Okay. I see.
All right? All right. Hey, I'm only interested in...
Are you hitting the mic with your hand or something?
Oh, it is. Okay, there.
Okay.
It fell off the table. Okay. All right. What if I was only interested in the 7 times 6? Right? I could divide that by 5 factorial, right?
Okay.
All right. So, right. So just so you know, I know that you know what I'm talking about. Erase the 7 off on the left side, and then put a line under that. Yeah, you just erase that, right? And then put a line under that, and underneath put 5 factorial. Okay, so the 5 factorial goes away. If I was to divide, I end up with 7 times 6. Right? So that's 7 times 6. So let's say that's the part I'm interested in.
Okay.
All right, now let's go back to now the original, we had 5 items, right? And I'm interested in picking 3 of them. 5 times 4 times. Let's go back to. Let's make it 7 because I want to. So let's say we have 7 items now, and we're going to pick 2, right? Now, so if I were going to pick out all 7, it would be 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, that's when I'm picking all 7. All right, and now I want to if I'm now let's say I've decided I don't want to pick out 7. I only pick out 2. All right, and so on the first one. On the first blank, I have 7 ways, and on the second one, there's 6 ways, right? So I don't want that 5 through 1, right? So what did I do? I divided that whole thing, that 7 factorial, right? And I divided by 5 factorial. So you need to start writing some of this down because I think some of that you need to be erased, right? So, all right. So this is what I do. This is the problem. Now I have 7 items, all right? All right. And so write down 7 blanks, all right? All right. And then go, to order all 7, it's 7 factorial, but go 7, 6, 5, 4, 3, 2, 1. And so now, instead of picking all 7, I want to pick out 2. So I know the answer is going to be 7 times 6, right?
Mm-hmm.
So, all right. So what I'm leading up to is the formula, right? So the total ways of doing this was 7 factorial, but I divide by 5 factorial, right? Divided by 5 factorial. All right. All right. So now I'm going to give you the formula, right? The formula is n factorial divided by n minus r in parentheses factorial. All right. Now let's see how the example compares with the formula. All right. Now, in the example, all right, what is n?
The total number of items you have.
Okay, so in the example, how many is that?
7.
7. Okay, so in the example, n equals 7, right? And then what is r? R is how many we're picking. So
Okay.
how many? So we're picking. Yeah, go ahead and tell me that.
We're picking
R
2.
is how many? Picking 2, right? So the top part, n equals 7 factorial. That agrees with our example,
Mm-hmm.
right? And n minus r is 7 minus 2, right? And 7 minus 2 is 5.
Okay.
Okay.
Yep.
All right. So, the formula itself seems complicated, but what you want to do is, let's say we have 10 items, and we're picking 3, right? So that would be 10 factorial, 10 minus 3 over 7 factorial, right? Right. So now I've shown you the formula. Now I'm going to show you how to use it, right? So far, do you understand how we got 10 and 7, right?
Yeah. Yep.
Okay. Because we're picking 3, 10, because I did some stuff in my head. So 10 minus 3 is 7, right? So now at the top is you'd go 10 times 9 times 8 times 7 factorial. Then at the bottom you have 7 factorial. So write that down. 10 times 9 times 8 times 7 factorial. And then at the bottom, you still have the fraction, and then 7 factorial. All right. Now you don't need to know what 7 factorial is now, and you don't even have to know what 10 factorial is. All right. But once you take this and you write it that way, now you can cancel this to 2 7 because you don't even know you need to know what 7 factorial is, and you don't even know you need to know what 10 factorial is. So after you write it this way and you cancel that, then you're left with 10 times 9 times 8. 9 times 8 is 72. 72 times 10 is 720. So there are 720 ways of. So we pick 3 items out of 10. Okay.
Yep.
Okay. All right. Now I'm going to give you an example where order is one place where order is important, right? And so let's say you have, okay, let's say you have 10 people, and you're picking, and it's a club. You have a group of people, and there are 3 positions in the club. You'll say you have a president, treasurer, and secretary, right? Right, and so you can even write underneath the blank PTS, president, treasurer, secretary, right? And so you need to pick, and also these 3 people, you cannot have one person having 2 different positions, right? So they're mutually exclusive, right? And so so how many ways are there to pick someone to be president? So I mean, let's say you have an election, right, in your club. Yeah, and so you have 10 people, you take a vote, right? And so anybody can be the president. So there's 10 ways. So now you've chosen your president. Now you have to pick your treasurer, right? Well, one person has already been chosen to be president. He can't be the treasurer. So now you're left with 9 people left, right? And so now you've used up 2 of your people. Now you have to choose who your secretary is, right? And so now there's 8 people left, right? And so you multiply that. That's 720. So we have 720 different ways of picking your president, treasurer, and secretary.
And this is all with order, right?
This is all with order because this is one example where the order was important.
Yeah.
Okay. All right. So the next thing is without order. Now, did you ever learn set theory in school?
No.
Subsets and stuff? Okay.
No.
Oh, all right. Oh, we learned that in when I went to school. Yeah, I mean, I'd learned that in high school, and then we had a lot of it in college, right? A set is just a group of items, right? And it's designated with brackets, and then you can list those things in the set: A, B, C, D, E, right? So you have a set of things, right? And then a subset is a set that is contained in that. So so go ahead and write this down. Have a left bracket and a right bracket, and inside go A, B, C, D, E with commas in between. Technically, your brackets are shown wrong, but it's the bracket that's curved. You know what I'm saying?
Does it have the point on it?
Has a point and it's kind of curvy, I think. Yeah. Okay. All right. So that is a set, and there are 5 items in that set, right? And then a subset is a smaller set. Well, actually, technically, everything is a subset of itself. But if you where a subset is a set that every item in the subset is also an item in the other set. So you have A, B, C, right, is a subset of the bigger set, right? Because every item, all right, you see the A, B, and C is also in that bigger set.
Yeah.
So that's called a subset. Okay? So without order, another way of saying that is how many subsets there are that contain 3 items. All right. So so here, order is not important. It's just a group of stuff. So you see here why the order is not important?
Yes.
The order is not important in sets. It's just a group of stuff.
Yeah.
Right? A, B, C. Right? So in this case, right, in this example, we want to know how many subsets of size 3 come out of a set of size 5. Right? So the way that shows up in a calculator is they use C. And on the left side, in small letters, you have an N. On the right side, you have an R. So go ahead and write that down so people can follow along on your calculator.
So right? Small c.
Now big C, and then to the left will be a small n, right? And then an R. Right? So do you see that on your calculator?
No. I don't think. Oh, okay, yeah. It's the same button as the NPR, the P one.
Oh,
but
yeah,
it's like a function.
A second function
yeah.
one. I have 2 calculators. I don't know if it's on this one. It's funny because I have on statistical calculators, you'll have that. I'm really curious about which calculator. Oh, yeah. Mine is 2 different buttons, but I have to hit the second function. Yeah, okay. It's on my scientific calculator, not my business calculator. Okay. All right. Now, let's go back to because so the C is for combination and the P was for permutation, right? So let's go back for the combination with order or called a permutation, right? So that formula was n factorial divided by n minus r factorial. So write that down. No, God, the fact, no, that's n minus r, that quantity factorial. Oh. So the factorial symbol goes on the outside. Okay, right, all right. Now, so I'm going to make a slight change to the formula for without order. So on the left side, erase the P and make it a C. And then I'm going to make a change to the right side. The noise level now. It's on my table.
It's better, but it's still popping a little bit.
Oh, okay. Okay. Now, let's in this example here, right, before I change that formula, right? Find some space and write 5 factorial, and then say we have 5 items, you're choosing 3, so you're going to go 5 minus 3 is 2, so it'd be 2 factorial, all right? Okay. Okay, all right, so that is with order, all right? Now, remember, with order, we get more, right? Because write this down. We have A, B, C, A, C, B. All right. Well, no, we don't have to go through all that. All right. Okay. We have 3 items, right? And how many ways can we order A, B, and C? All right. Well, that's going to be 3 factorial, right? All right.
Mm-hmm.
All right. So we have 3 items. We have 3, which is 6, right? So that's how many more we're going to get. We don't want those extra ones, right? So what we want to do is divide. Okay, now okay, the 5 factorial over the 2 factorial, I want in the denominator, I want a 6 factorial. Yeah, just no, leave the 2 there, all right? Leave the 2, but I want you to multiply it by, and then to the left of the 2 goes 6 factorial. Okay, all right, and then draw your line over a little bit so we know that it covers. All right, now, remember in our example, we have A, B, C, D, E. We have 5 items in the set, all right? We're picking 3, all right? So if we were to do it with order, it'd be 5 factorial divided by 2 factorial. But we know we're going to get too many. You know why we're getting too many, right? Because
No,
because that is with order. That because like there are 6 different ways in the example of A, B, and C. There are 6 different ways of ordering A, B, and C, right? Because we have A, B, and C. You have 3 items, right? You're going to pick. You want to find out how to order all 3, right? So if you're using all 3, it's going to be 3 factorial, right?
Mm-hmm.
Okay, so you're getting more than what you want because in this is without order. So we just want A, B, and C. Yeah, we just want A, B, and C. Right? We don't want B, C, A to show up. Right? So we have to divide it by how many extra ones we get. Right? So now let's go back to the formula. So what we want to add in there is R factorial. All right, so go back to the formula, and then off to the left of the left parenthesis, go R factorial. Right there, yeah. Okay, so that compensates for having those extra groupings because of the order. You see what I'm trying to say?
Yeah.
Okay, all right. So, let's what did I say on the? So look at the difference on 10 choose 3 with order was 720. Okay. So we're going to still do the same thing. We're going to have 10 items, and we're choosing 3, but without order. Let's look at the difference. All right, so that's going to be 10 factorial, right? And then 10 minus 3 is 7, so 7 factorial, and then times 3 factorial. So that it matches the formula, put the 3 on the left side and put the 7 on the right side. All right. So the R is 3. So that's 3 factorial, right? And then the n minus r, that's 10 minus 3 is 7. So it's 7 factorial. All right. So now, we've used the formula. So here we're going to go 10 times 9 times 8 times 7 factorial, right? Divided by 3 times 2 times 7 factorial. All right, and then underneath go 3 times 2. The 3 times 2, we don't need the 3 times 2 times 1 because
Yeah.
Yeah. So you can stop at right before the 1, right? And then that's times 7 factorial. So the 7 factorials cancel out. You can cross those out. And the 8 divided by 2 is 4. And 9 divided by 3 is 3. What'd you do? What happened?
Nothing.
Okay. Okay. All right. So now the 7, you don't even need to know what the 7 factorial, it cancels out. So 8 divided by 2 is 4.
Mm-hmm.
And 9 divided by 3 is 3. All right. So write that, do the arithmetic there. So, and so you, right. And then times 10. Okay. I mean, can you do that up with the fraction? All right, you go have 8 divided by 2 is, so cross out the 8, cross out the 2, make it 4. 9 divided by 3, cross out the 3, cross out the 9, put the 3. And then 3 times 4 is 12. 12 times 10 is 120. Right. So there are 120 ways to pick 3 items out of those 5, where it's just a combination, order doesn't matter. But with order, you get 720. Right. So that's what that R factorial is for. Okay.
So there's more with order.
Right. Yes.
Well,
I mean, it look like you have in our example we have A, B, C, right? So without order, A, B, C, it doesn't matter what order they're in. But with order, I mean, you have A, B, C, and A, C, B, right? And you got B, A, C, right? I mean, so I've given you, there's 3 right there, right? But going back to our permutation, we have 3 items. How many ways can we order 3 items, right? Well, that would be just 3 factorial, right?
Okay,
that just goes back to, see it now?
I was not thinking of it correctly.
Yeah. So you have, So that's why you're getting more, and you need to compensate, and that's for that by dividing by the R factorial.
Okay.
Okay. It's funny. I didn't plan on this. But the example that I gave was about 10 and 3 is the example they used in the book. I didn't plan on that. Let's see. Oh, okay. And here's an application of that. We did it. We had 10 items. We chose 3. And the example they gave, you have 3 employees are selected from 10 to go to the same plant or factory. So in the example I gave with 10 and 3, this was 3 employees that you're pulling out to go to a certain factory or a plant, right? And so how many ways can you select those 3, right? So here is 3 employees. This is just 3 employees. One isn't a president or secretary or vice president. There's nothing special about each one. All they're doing is just picking 3 employees to send off to a plant somewhere. And so in this, you're picking 3 out of 10. There's 120 different ways you can choose 3 of them. All right. All right. The other examples have to do with probability. We'll do that next time. Okay. Here's a use for this, and then we'll call it quits. Here's a non-probability use for this. Oh, and here's another way. So you can clear the screen. Okay. Now on a calculator, you're going to go NCR. That's what you'll see. I showed you that, the button, right?
Yeah.
But in a math book, what you will see is an N. So write this down: an N over an R. Right? And then no, it's not a fraction. Just an N over an R. Yeah. So take away the line and just put an R underneath the N. All right. And then have big parentheses that go over both of those. All right. And how that is read is N choose R. That's how that is read in a book. N choose R.
Okay.
Okay. All right. So, all right. Now, so let's talk more about that. Right. Let's look at. So write this down. 10 choose 0. So how would you write? You write 10 choose 0. Yeah, that's what that means. All right. Now, right now, some of these we can do without doing the arithmetic or algebra. Right. So you can just think about this. 10. How many ways are there to choose none of them?
0.
0.
Or,
no,
or
there's
1.
One way. Okay. All right. All right. And all right. And now let's look at it. You have 10. Choose 10. All right. So write that down somewhere. Remember, order is not important. So you have 10 items. How many ways can you choose 10 of them?
That would be 10 factorial.
No. Not good. There's no arithmetic involved here. There's no algebra. There's no arithmetic. You just have 10 items, and you're going to choose 10 of them. And order doesn't matter.
So
also
that's
1? That's also 1.
Okay.
Okay. Now, so here, I want you to see a pattern here, all right? So, when you have 10 items, choosing 10 of them, right, is the same amount as choosing none of them. Okay?
Okay.
All right? And let's look at what's all right, let's look at 10 choose 1.
So that'd be 10.
Right, let me sure, no, that's oh yeah, you're right. Yeah, that's 10. All right. All right. So yeah. So you have 10 items. How many ways can you choose one of them? Yeah, there's 10 ways, right? All right. And what about 10 choose 9? All right. Now, another way of looking at is uh, 10 choose 9. That's the same as saying how many ways are there not to choose one of them, right?
Okay, yeah.
Which is, that's 10, right? Right? You see how um, choosing a certain amount is going to be the same as not choosing the others. You see that? Right? Choosing 10 is the same as not choosing any of them. Choosing one of them is the same as not choosing 9. You see what I'm trying to say?
Okay, yeah, I think so.
Okay, all right. So there's okay. All right. So these are the simplest ones right here. But I mean, um, here there's really no math involved, right? But here, so choosing 10 out of 10 is the same as not choosing the others, or choosing 1 is the same as choosing the other 9. Right. Now, have you ever heard of Pascal's triangle?
No.
Okay. All right. This is Pascal's triangle. So you have to clear the screen because it's going to take some space. All right. At the top, put a 1. All right. And then underneath that, write a 1, make a triangle, a 1 and another 1. That's just to get it started. Okay. All right. Now, so that's 2 items, right? So on the third one, we're gonna have 3 items. So you're gonna so you're gonna, that 1 is gonna continue down, right? Except now the middle number is gonna be the sum of the numbers above it. So it'll be 2. All right, and so to the left we have 1 on the next row, and then to the right we have a 1. We're going to make a triangle. Now we're going to have 2 more numbers, and so we're going to add the 1 and the 2 to get 3, and the 2 and the 1 to get 3. So we're always.
Is there going to be four entries in this line? Okay.
Yeah, right. Yeah, because the sides of the triangle will always be 1, but on the inside, it's going to be the sum of the numbers above it.
So 3 and 1?
Well, now it'd be 1 plus 2 is 3. So we have the 1 and the 2. So in between that, you're going to add those 2 numbers together. So the 1 and the 2 is 3. So 3 goes down there.
As in right there?
No. You're going to have you're going to add 1 and 2 together. So underneath that, in the middle, you're going to have a 3.
So that's literally the middle right there with a 3.
No. Because we're going to have 4 numbers.
I don't know how to write it.
Right. We're going to have 4 numbers across. So you can have 1, 3, 3, 1.
Okay.
Okay.
There we go.
Yeah. Okay. All right. So where that 3 came from was you added the 2 numbers above it. Right. So the next one, right, is going to be 5 numbers. So the triangle continues. You're going to have 1.
So when you say add the 2 numbers above it, do you mean like that?
Right, like that.
Oh, okay.
Yes.
Okay.
Okay.
That's where I was not understanding. Okay.
Yeah. All right. So the 1's still going down the side. All right.
So 4.
And so
9.
right,
and 4.
For you multiply, no, 6.
Oh shit, I did.
Yeah, right, yeah. Okay. All right. And we'll do one more. All right. Be 5, 10, 10, 5. Mm. All right. All right. What I'm going to show you now is um, remember uh, the binomial x plus y, right, to the n. So write that down someplace. All right. Make it now. They give parentheses. All right, and then not a 2, but an n.
Oh.
Okay. All right. So we're going to expand that out. All right. We're gonna multiply that out. All right. So let's say that's um, okay. So let's look at, as an example, x plus y to the 5th. Okay. Yeah, parentheses, that whole thing, we're going to take it to the 5th power. Right? So we're going to have go xy, make 6 of them, xy's.
Just across.
Yeah. Okay. You might go ahead. I've saved the triangles. Go ahead and erase the triangle so you have some space. So go ahead and erase it. We're gonna. So that whole thing is called, and that continues on forever. So that's Pascal's triangle. Right. We're gonna take it to the 5th, right? And now, yeah, and give some more space because we're gonna need some coefficients. Gonna need 1, 2, 3, 4. You're gonna need 6 of them. All right. All right. So and we will be adding these later, but after you put in the coefficients, you put in a plus. Right. Now on the x's, the first x will have an exponent of 5. Right. And the next one will be well, no, the first x. The next x will be 4, then 3, 2, 1, 0. Okay. And then the y starting on the right side is going to be 5, 4, 3, 2, 1, 0. Okay, right. So all we need now are the coefficients, right? And this is where Pascal's triangle comes in, right? Now, the what we want, we have 6 terms, right? So we want the row that had 6 numbers in it, and that was the 1, 5, 10, 10, 5, 1. So that's what fills in there. It's going to be 1, 5, 10, 10, 5, 1, and then plus signs here.
So coefficient of 1.
1.
And then 10.
10. No. There'd be the 1, 5. You had to erase the triangle to save room, but that last part of the triangle was 1, 5, 10, 10, 5, 1.
Okay.
Okay, that came straight from the triangle.
Okay.
Now you can simplify that, you don't need the 1 anymore.
Mm-hmm.
And also, when you have x to the 0 is 1. So anything with exponent 0 can just go away. So you can erase that, right? And erase that, and then put pluses everywhere else. And then fill in your pluses. Okay. So that is using Pascal's triangle to expand a binomial raised to a power, right? The Pascal's triangle will give you the coefficients. Okay?
Okay,
All right.
yeah.
All right. Okay, so now we're going to do it a different way, right? So go ahead and leave that up there, all right? All right, so now underneath that first term, I want you, see there were, see if I hope I'm doing this right. All right, we have, yeah, okay. All right, so we have, so underneath that first x to the 5th, I want you to go 5, choose 0. All right, and then underneath the second term, it's going to be 5, choose 1. Right, and underneath the third, it'll be 5, choose 2. Then 5, choose 3. Then 5, all right, choose 4. And then 5, choose 5. Okay, all right, so you can use Pascal's triangle, or you can use that. All right, so 5, choose 0 is 1. 5, choose 1 is 5. 5, choose 2 is 10. 5, choose 3 is 10. 5, choose 4 is 5. And then 5, choose 5 is 1. Okay, so that gives you that gives you the coefficients.
That's interesting.
Yeah. All right. So anyway, that it's too bad you didn't do Pascal's triangle on a side sheet, or if there's, because you didn't have a lot of room. That's why I told you to erase it. But the 1, 5, 10, 10, 5, 1 was the 1, 2, 3. That was the 6th level of trying, and so you could do it over again if you want to. But that was the 6th level of this triangle, was 1, 5, 10, 10, 5, 1. Okay. So, but after beyond this, the you don't want to make, we already used up most of the page by doing the Pascal's triangle down to down to 6 levels, right? So if you were to do a 10, that would do, you could easily make a mistake, and I mean that would take up a lot of time to do Pascal's triangle for 10. So let's look at, and then after this we'll call it quits. So you can erase all that, and let's look at x plus y. So we're not going to use Pascal's triangle. We're going to use the combinations, and we're going to now take it to the 10th. Okay. All right. So that means we will have, we're going to have x times y, and this time you'll always have one more term. So instead of 10, you'll have 11. So you have 11 of these. So I don't know how. So you have to start way to the left side. All right. All right. 1, 2, 3, 6. All right. So, so make sure you have the 11s. So you're always going to have one more than the power. Okay. All right. And so the x starts off at whatever the exponent was. So that'll be 10. And then it decreases by 1, right? You got it. 8, 10, 9, 8, 6, 5, 3, 2, 1, 0. All right. And then, yeah, oh, you're ahead of me. Great. Now later on, we'll simplify it. All right. So, so underneath the first term, we're not going to compute this for now, but that's going to be, what is it? Be 10, choose 0. The next one will be 10, choose 1. Right, and then 10, choose 2. Right. So it's going to be, it looks like it's going to be the whatever the exponent is of the y. Right. Choose 3, 10, choose 4. All right. So all of those will give you the coefficient that you need, right? And the 10 stays the same all the way across, but the bottom number, the number that you're choosing, is going to follow whatever the exponent of the y was. Okay. Now, we know right away that without doing any computation, how many ways are there not choosing? Well, there's one. So underneath that first one, we don't have room to put all the coefficients in. But underneath 10, choose 0, that's 1. All right? And then 10, choose 1, there's 10. Okay? Now let's move to the right side. We have 10, choose 10. All right? There's one way to choose 10 of them. All right? And then 10, choose 9. All right? There's 10 ways. Okay? So now, you don't have to compute every one of these now. I want you to show you. Now, I want you to draw and make a semicircle. Go from that one over to the other one. Just a semicircle. All right? And then the same thing with the 10. Make it big enough. Okay? All right. Now, on the 10, choose 8. I want you to draw that line, make a semicircle to the 10, choose 2. And then the 7 to the 3, all right, and the 4 to the 6. Okay? All right. So you only, so you have 2 of them were given, they're easy to do, right? The 1 and the 10, 1 and the 10. All right. Now, the 10, once you've computed 10, choose 2, that's the same as not choosing the other 8. All right, so they're going to be the same. So once you've computed that 10, choose 2, you've got the answer for 10, choose 8. Right? Because if you think about it, right, choosing 2 of them is the same as not choosing the 8. Does that make sense?
Yeah.
Okay. Now the same thing with the 3. Choosing 3 of those is the same as not choosing the 7. So that's why they're going to be equal. And then the 10, choose 4, choosing those 4 is the same as not choosing those other 6. Or choosing the other 6. I said it wrong. All right. So let me say that again. Right? All right. Choosing 2 of them Yeah. Oh, I hope I didn't. Yeah. I think I said it right. Yeah. All right. So, yeah. So yeah, choosing the two is the same as choosing the other 8. Choosing 3 of them is the same as choosing the other 7. Choosing 4 is the same as choosing the other 6. And then you have 10, choose 5. All right. So, so anyway, you in this example, you only have to choose, because we got the 2 on the left and the 2 on the right, the coefficients. We got 1, 10, 10, 1. Those are the easy ones. All right. All right. And so, so we only need to compute 10 choose 2, 10 choose 3, 10 choose 4, and that'll give us 6, 7, and 8, and then we have to go to 10 choose 5. All right, so that's and then of course for the coefficient of 1, you don't have to write 1, and then anything with an exponent of 0, you can erase that. So here's how you can expand x plus y to the 10th power. Using your combinations. So if it's like 5 or less, you can use Pascal's triangle, right? But if it's more than 5, you might end up doing this. Okay, does that make sense now?
Yep.
Okay, because in higher level math, you might have to do something like this. You might, I've seen a professor work on a problem, and he took the whole chalkboard to solve the problem because it got messy. It was something like this.
No, thank you.
So that's how you would expand that. All right, and the complicated thing has always been finding the coefficients, because the exponents, the x is decreasing from n to 0, and the y is increasing from 0 to whatever n was. And so that's the easy part. The next part is coming up with the coefficient. So this is how you would, when it's the power is big like this, you would use these combinations like that.
Well, Mafovich says that your explanation is good.
Who says that?
The guy that was watching earlier.
Oh, what's his name?
Mafovich. He's actually an admin on the channel.
Oh.
So he can.
What does that mean?
He can ban people that are disruptive or abusive or whatever.
He's from Discord or what?
He's from Twitch.
What is that?
It's the streaming service we're on right now.
Oh, okay.
He's been around a while.
Oh, okay. So he's doing his job, or
he's just hanging out and watching.
Okay. Oh, but I mean, is he supposed to monitor what's going on, or
he can if he chooses to.
Oh, okay. But he's not being paid to.
No.
Oh, all right. Do you know what part he liked? Is he still there?
Yeah, he's here.
Okay.
It was the explanation. This explanation right here.
About expanding.
How to expand it? Yeah.
Or how to expand it. Okay. Anyway, so on your own, do Pascal's triangle, so you can see that if it was 5 or less, those numbers will give you the coefficients. If it's more than 5, you don't want to make a very big Pascal's triangle. But I mean, you could, right? If it gets more than 5, it's easier to do it this way, I think. Right. So that's how, even though we're using something out of discrete mathematics and out of probability, it's something that is also used in just algebra now. Okay.
Well, you were saying when you were just about finished with your degree in math, you were talking to your buddy and you're like, so what does that mean? We're about to get our degrees in math. What does that mean? It's like, well, that means we're really good at algebra.
Yeah.
Which means that algebra, to me, that sounds like algebra is everywhere. Like you have to use algebra everywhere in math.
Yeah. That's That's why you never master algebra. It just you you always get. I'm always learning stuff. I'll go on some math channel and I'll see something that learn something I've never knew before. Um, and the principles of algebra, there's I think it's there's not if you on just a few pages you can list every principle of algebra, right? all the rules, right? But knowing how to use those rules is what takes time. Um, I was teaching uh, at a high school one time, and I was required that the school had this idea that we're going to teach mastery, that we're going to say that they've mastered it, right? And and these people didn't know what they were talking about. I mean, you don't master algebra in high school, but had to state, oh yeah, he's mastered it. And if I didn't say that, I would get in trouble. And so I said, okay, all right, yeah, he mastered, But it's just something you always have to work out, and that's how what having a degree in mathematics means is you just get good at algebra, right? Because you just that because it's like I don't know, it's like learning a language, right? I mean, I could I could take a 1 semester course in Spanish, but to really know it, I'd have to read a lot of literature. The only one I could think of is Don Quixote. But in whatever foreign language, I'd want to. I wouldn't just take one course. I'd want to, learn its literature. I'd go deep into it. I'd converse with people. I do a lot more than just learning the rules of some foreign language, and that's sort of like with mathematics. Is you keep learning it, and so I had I and I went beyond what was required. I've maybe combined math and statistics. I might have 20 courses in math or statistics, and so it's and so I don't have everything memorized in all the courses I took, but by doing all that stuff, it just makes you a better thinker, and you can. It just comes. Yeah, that's the only thing I can say is I'm no expert in calculus but I know my algebra.
You are an expert in algebra.
Yeah. But even then, I'll still learn something will come up. So anyway, you can spend some time what you want to do next. I still have my probability book. Probability can get hard. I can tell you that. This was just one section out of a chapter in probability. But you can do this, so the hardest subject is probability. I think the easiest subject is trigonometry. So you can decide for next week what you want to do. Okay.
I think I want to do trig next time.
Oh, okay. Yeah, trig's fun. Yeah, okay. Yeah, and yeah, I know my trig, so we can,
okay.
Yeah, we can do that.
Good deal.
I've taught it, and that was another thing you had to know in calculus. You had to know your trigonometry.
Oh, I see.
Yeah, that's
So you have to take trig before calculus.
right. If you see a course called Precalculus, basically what that is college algebra plus trigonometry. So, so if let's say you have college algebra, and then you decide you want to take calculus, and they say, well, you need to take precalculus first. Well, you don't need to take precalculus. You just need to take trigonometry.
I see.
Yeah. So yeah. So but trigonometry it is pretty simple. People study physics and engineers. They study trigonometry not for the original purpose of it. The original purpose was about measuring triangles. But right now, triangles, it goes from 0 to 90 on a triangle, right? But there's a pattern in trigonometry that shows up where you can have any number for an angle. You can go beyond 90. You can be beyond 180. You can go negative. And so this pattern sets up. You ever heard of a sine wave?
Nope.
No. Okay.
You want to save that for next time, though?
Yeah. Okay. Yeah. Anybody that works with electricity know what a sine wave is. I thought you knew. But it's that sine wave that comes out of trigonometry, and that's because you have a trigonometric function, a sine function, right? And because you can go beyond 90 degrees or less than 0, that'll give you this pattern that increases over time. And so people that study physics and engineers and stuff, they're interested in this pattern that shows up. It'll make more sense when I started about triangles, and then if we're stuck with triangles, we have to, because one side will be 90 degrees, right? And we're interested in one of the other sides, right? So if one side is 90 degrees, that means the other two have to be less than 90 degrees. So if we restrict ourselves to a triangle, right, that we can only go up to 90. But we make this little change, and we can expand the whole idea of this function by making this little, and it'll make more sense next week, but you can just go on forever. We don't have to restrict ourselves to 90 degrees. If you want something easy, it's really a simple subject. And so if you were to decide probabilities, I think the hardest subject in mathematics. Okay.
All right. Well, that is one section in one chapter of discrete mathematics, ladies and gentlemen. All right. That was good.
Yeah. Well, we only covered actually 3 things. Something with multiple tasks, permutations with order, and combinations without order.
Okay. Well, there you have it.
Okay.
And we'll go ahead and turn that off.
Okay.